Now let's move on to answering some new questions. If we go back to our original data frame and look at those first 5 entries, we see the number of violations of a particular camera on a particular day. What we would like to do is see what's the largest number that I ever experience in this column, the largest number of tickets issued by a single camera on a single day. In order to do that, we'll be using the max method of a particular series, and what we would like to find is the maximum value in this particular column. So the series that we wish to create, let's name it num violations, and that series is the violations column of the speed data data frame, accessed via this syntax right here. If we then call this particular series max method and print that value to the screen, we see that the largest number of violations issued by a single camera on a given day is 479. Now it's nice to know that the largest value that occurs is 479, but from what we've done so far, we have no idea which row of our huge 118,000 rows gives us this value 479, and we don't want to visually examine it, searching for that number ourselves. So luckily, series also come with an IDX max method, and that IDX max method tells us the index at which this maximum value occurs. Thus, if we call the IDX max method of the num violations series and ask Python to print that value to the screen, it gives us this number, 33,185. So that's telling us we won't find the number 479 until we've scrolled all the way down to row 33,185. Instead of scrolling down that far, like we would in an Excel sheet, let's just ask Python to print that row to the screen for us. And recall that the way we do that is by going to our speed data data frame, calling its iloc method, and passing it the row we wish to see through these square brackets, just like we would access an element of a list, and we pass it that number, 33,185. Python then prints this to the screen for us, and what we can see is all the information we might want to know about when this 479 value occurred. We see the value 479, the number of violations. We now see the camera ID, Chicago 149, the address, 4909 Cicero Avenue, and the date, May 23rd, 2015, which happens to be the Saturday of Memorial Day weekend, a historically busy time in Chicago. So this answers our second question of what's the most number of violations given by a single camera on a single day in Chicago, but it doesn't help us get a feel for if this camera gives a lot of high violations or if this was something of an anomaly for this camera. It's very plausible at this point that just because it was Memorial Day weekend, we might be seeing a lot of violations, and there may be some other camera that more frequently records high numbers of violations. So if we wanted to get a feel for which cameras distribute lots of violations, what we might want to do is take our data frame and sort it according to the values that are occurring in the violations column. This is certainly something we could do in Excel. It's very easy to select all of your Excel sheet, hit the sort button, select the column by which you want to sort, and then see your data reorganized. Because DataFrames are Python's version of Excel sheets, this is possible inside of Python as well. And what we're going to do to sort our data frame is use the sort values method that comes along with the data frame. So what we need to do is give the name of the data we wish to sort. We need to call its sort values method, and this method does take in something as a parameter. What it takes in as a parameter is the column by which you want to sort. So to show you what that looks like, the data frame that we wish to sort is our speed data frame. We call its sort values method using the dot and then the name of the method sort values. And the parameter that we need to pass to the sort values method is the column via which we wish to sort. In my code, I'm also going to add this additional parameter, in place equals true. And all that really means is that I want to take my data and actually sort it and make the change to the data frame permanent instead of just asking Python to print me what a sorted version would look like. With that cell executed, let's now run this cell, where I now ask to see the last 10 entries in the speed data frame. Notice that this very last entry in the data frame now corresponds to the entry we saw before, Chicago 149, May 23, 2015, 479 violations. And the violations we're seeing before that are the next highest number of violations, and the next highest number of violations, and so on and so forth. Now what you can see here is that in fact every single one of those violations is given by the same traffic camera, Chicago 149, 4909 North Cicero Avenue. And every single one of them occurs in 2015, mostly over the summertime. It gets even worse if we ask to see the last 20 entries in our data frame. Again, every single one of them has the same camera ID, Chicago 149, 4909 North Cicero, and almost every single one of them is over the summer in 2015. So what's really behind something like data science would be seeing an observation like this and saying something is obviously going on with this camera and this time of year, and coming up with a hypothesis like perhaps there are baseball games on each and every one of these days. And so that's something that you might explore in a data science class and is one of these really cool applications of Python to these large data objects.